Hello, everyone. We are back here on the channel, and I have AR with me from Metal Beer. We're going to talk about MiroD for Kubernetes debugging or local debugging when you have to debug things and when your local environment, but at the same time have a Kubernetes cluster that you are managing. Could be locally, could be on Azure, could be another cloud. Welcome, Eyal. We're looking forward to see what you have to show to us today.
Thanks. Thank you for having me. I'm excited to show me your to everyone.
Yeah, tell me what's in a sentence what you're going to show us today.
Yeah. So MirrorD, as you said, lets you debug an application that's running in Kubernetes, but that you're now developing locally. When we'll do a deep dive, will be clearer, but it cuts your feedback loops because you don't have to deploy to Kubernetes in order to test your microservices anymore.
That sounds great. I just put the link there, metalbeer.dev. That's where I can melody.dev and also the company. If you want to follow the company, I'm going to put the links later here. But let's jump in, and I'm going to share your screen. You have some slide deck that you want to show us. Just
Yeah.
play slide deck there, and yeah, go for it. I'm going to ask questions along the way for sure. That I'm going to try to make the questions that people watching wanna ask as well.
Mm-hmm. Great. So I'll just go ahead and you stop me when you want to ask something. So MirrorD, as we said, it lets you run a local process, and this is a completely locally running process in the context of your Kubernetes environment. And when we say context, what we mean is that the local process now has access to everything in the cluster. So databases, other microservices, third-party APIs that are only accessible through the cluster, storage, etc. And so your local process essentially thinks that it's running in the cluster. And this lets you test your microservice from your IDE, from your local machine, in cloud conditions, in a much simpler way than what ways are currently available. And the value this brings is twofold, right? So for the individual developer, where before, in order to test your single microservice in the context of your entire application, what you usually had to do, and this is assuming if you're in a relatively mature company where it's difficult to run everything locally on your machine, like all the microservices, databases, etc. So what you usually had to do was test locally, create a pull request, go through code review, go through CI, unit test, etc. Then deploy to a staging environment and test there. Whereas with MirrorD, because you can connect your local process directly to the cluster, this whole cycle is significantly shortened because you can continuously iterate against your staging environment without going through all these other steps. So this is the value for the individual developer, but then also for the organization. These staging environments, which a lot of organizations put a lot of effort into, they usually become bottlenecks, right? Because usually, if it's a good staging environment, it has data in the database, it has all of the microservices running. It's not something that you want to have running for every developer in your organization. So you have shared environments, and these shared environments become bottlenecks because concurrent usage by multiple developers is not really possible. When one developer is testing their untested code, then another developer can't validly test their own microservice. And yeah.
Is that common question that people ask is, do I have to commit my code, push my code to Git, to be able to debug?
So absolutely not. It's exactly the same flow as debugging locally. All you have to do is make your changes, click debug, and you're good to go. Your service is running locally, but it thinks it's in the cluster, and we'll see that in the demo.
That sounds great. I just put the link here for that's the open source project, and if you are interested to have a look, just that's the first link. And you can talk along the way about the open source project and how that all get started as well.
Mm-hmm. Yeah, so, but as I was saying, the staging environments, they become bottlenecks, and MirrorD breaks this bottleneck because MirrorD doesn't actually deploy your code to the cloud, right? So the stable service is running in the cloud. It's still there. It's still answering requests. It doesn't really know that you're using MirrorD to debug in this environment, and this applies to every other developer who's using it at the moment. So this lets multiple devs use the staging environment at the same time. We're going to do a quick explanation of how this is achieved, and then we'll do a demo. So MirrorD is composed of two main components. One is running locally, and it's called the MirrorD layer, and the other is running remotely, and it's called the MirrorD agent. And the first thing that happens when you run MirrorD is it creates the agent on the cluster. Now, for this example, let's assume you're a developer that's working on your company's user service, right? And you have the user service version 1.0 running in the cloud, and you're now developing version 1.1. So the MirrorD agent starts, and when you start MirrorD, you select the pod that you want to, we call it target, right? So in this case, I would select the user service version 1.0. This is the service that I want my local process to import the context from. And you can already see what this context is that we're talking about, but we'll dive into it in a minute. So the first thing is that the agent is created on the same network namespace as the target, the user service 1.0. Of course, the user service is unaware that the MirrorD agent is running there. And then the next thing that happens, so the MirrorD layer essentially wraps your local service. So you're just running a binary, and the MirrorD layer is injected into the binary, and this is where the sort of magic happens. It overrides all of the input and output syscalls. So essentially, it takes all of the sensory information that your process receives or sends out, and proxies it to the cloud instead. So if your process, for example, tries to read a file, MirrorD would intercept that and read the file from the cloud instead. And it does the same for environment variables, for DNS requests, for incoming and outgoing traffic. So basically everything that your process receives or sends out. And then the agent does the complementary part of this, right? So it receives these requests and carries them out on the cluster. So again, if your processes try to read a file, it's going to ask the agent for that file from the user service running on the cluster, and it's returned from there instead of from your local machine. And it happens again for traffic, for DNS, and for environment variables. You can see that for incoming traffic, we can mirror the traffic. So the process is completely unaware that we're running there, and we'll see this later, we can intercept it entirely. And so the result is that your binary, which is running, completely, you haven't made any changes to it, you haven't made any code changes, etc. It thinks it's running in the cloud because all of its input and output is coming from there. So this is how we achieve this import of cloud context at the process level. And this is also what lets us agnostically support basically everything, right? Because as long as your process, we override libc syscalls, which are essentially used by all languages except Go, which we have a separate solution for. And because we're running at the process level, then we don't really care what's running around the process in the cluster. whether it's communicating with a database or another microservice, or there's a service mesh, or maybe it's even talking to something outside of the cluster. We don't care because it's just network traffic to us. So that's a short explanation of how MirrorD works. And yeah, now we'll do a quick demo. And for this demo, we're going to use demo or test cluster provided by Istio. It's called the Book Info application. You can find it on their website. And this is what it's composed of. It's basically a sort of, IMDb site for books, or I don't know, Amazon, I guess, would be a more fitting example. And there's the product web server written in Python, which queries the review service and the details and ratings services, all written in different languages, to give you composed sort of page of info about a specific book.
Just for me to get, see if I understood as a developer, everything that you told me, like the main thing we have like let's say that we have this application here running on our KS cluster. We normally have like a CI/CD pipeline. We deploy the latest version on let's say Azure Kubernetes service, and now I want to debug one specific service that I want to debug, the Python code or debug one of those components. Mm-hmm. And that's where MirrorD come in place. And I now going to read back all the traffic to just debug one or even more than one. I think it can also do more than one at the same time. And but ours have all these latest version deployed on this shared environment, like you said, like a Kubernetes cluster that could be running centralized place when you have a team of multiple developers working on that. And if you never had this problem before, you're probably going to have if you're new on Kubernetes. Like, it's very common on Microsoft, people working with Azure Kubernetes Service, having this kind of problem where they start developing, they say, now I have a problem, I want to debug these, I don't want to stop my cluster that's running on Azure Kubernetes Service because there are other developers that need those dependencies. And these microservices, I cannot just break that in the meantime. And that's just to keep clear for the developers, that's going to keep working. Like you said, we're not going to break anything else you're not going to be a noise neighbor, you're not going to break the cluster for the other developers that will be working. Is that correct?
Yeah, absolutely. And this is just a sample application. You can see how complex it already is. You can only imagine what sort of deployments people are running, in real life. And keeping these environments stable is a real difficult job. Yeah. So especially with people, constantly deploying new code there. So MirrorD helps avoid that.
Yeah, let's do the demo, and people are going to get the idea when they see that, running. And
yeah, okay.
So your environment, you're going to be using Visual Studio Code, correct? You have an extension.
Yes. So I'll be using Visual Studio Code. First of all, I have the application deployed on Azure Kubernetes Service. As you can see, there are no sort of MirrorD components here. It's only the sample application deployed. And for this example, let's assume that I'm a developer working on the product page. So I have the product page code running in or loaded into VS Code. And at this point, I don't have MirrorD installed, so let's install it in VS Code real quick. I haven't mentioned, but MirrorD comes as a Visual Studio extension, VS Code extension, or an IntelliJ extension, or a CLI tool. So we'll focus on the VS Code extension for this demo.
That's great. Let's start from scratch. Start the extension.
Yeah, there's no rabbit in the hat. So
yes.
Great. And what this did was add this little thing
You can
here.
hide this thing. You can hide if you want. You just hide that. Yeah.
Oh, whoops. Yeah. Okay. So yeah, so it added this. This is a menu and the button. The button doesn't do anything. It only enables MirrorD for your next execution of your code. So, sorry. Just before we enable MirrorD, let's make sure that our code runs, and it does, and it's completely local. I haven't done anything yet. But now let's enable MirrorD. Let me remove this configuration, which I had from previous execution. Yeah, so this is completely unconfigured MirrorD. And I'm going to execute the code again. And now MirrorD is going to ask me what pod I want to target. So I'm going to target the product page pod. Okay, so it's running with MirrorD. Now I have the cluster exposed to the internet. So for our first sort of quick demonstration, I'm going to set a breakpoint here and make a call to the cluster.
Just for people to understand, like you had your cluster, your Azure Kubernetes Service cluster on your kubectl context to be able for the extension to have access to the pods, correct?
Yeah. Sorry, yeah, that's correct. I had to configure my kubectl context to have the Azure cluster.
Sure.
So, so I made a call to the public IP. That's where that's directing to my cluster on the internet. And this is still, it's still running. Like the request wasn't blocked, but I received the request here. I hit my breakpoint, and this is the first sort of initial use case. Is just if I want to see how my process handles an incoming request, right? So, yeah. So this is the first or the most basic use case of MirrorD. I'm going to let that run. But now, what if I want to see how the website shows my my response, right? So let's make a quick change to the code. So I'm going to stop execution. I'm going to look for this. I'm going to change this to this. And now we have our first encounter with the MirrorD configuration. So I go to settings, it creates sort of a basic JSON. And one thing I can configure is the incoming mode, where it's by default mirroring, but I can change it to stealing. And if I execute it again, let me choose the product page again.
And now that's going to be running the version that's on your machine.
Yep, that's correct. So if I refresh this page, and there we go. Now it received the request, the response from my local code. So that's traffic stealing. If we dive into the configuration a little bit, and one of the nice things about MirrorD and the way that it technically works is that it's very granular, right? So because we individually handle the different functions of the binary of the process, so networks, file system, environment variables, etc. We have very granular control over what runs where, locally, remotely, etc. And this is a blocker for a lot of these similar solutions, because sometimes you want maybe there's a file or dependency that's local and you don't want to get it from remote. Maybe there's an environment variable that you want to use locally. So this is all configurable through MirrorD-JSON. I'm not going to dive into it in this demo, but it's just good to know. Another example, by the way, is outgoing traffic. What if I want to write to a local database instead of a remote one? So with outgoing, I can specify a filter of where outgoing traffic will go based on host, based on IP, based on port. So there's very granular configuration. I'm going to show another example. So I'm going to keep this running, and I have the rating service.
A little bit more.
Very good.
There we go. Yeah.
All right. So I have the rating service. So the product page was written in Python. The rating service is a Node service, and I'm going to want to debug this one as well. Maybe I'm working on a feature that includes both of them, and I want the rating service to have the context of the remote rating service, of course. So let's do that. Let's make sure that we are stealing traffic. And just to show you so right now it's we're getting 5 stars and 4 stars from these 2 reviews. And I'm going to already change it. Sorry, George, but your book has received 1 star and 1 star. And of course, I need to turn on enable MirrorD. Select the rating pod. Let's make another request.
Yeah, that flexibility for you to pretty much debugging what's running in there. You just getting the breakpoints, but you debugging what's running in there, and you can make some tweaks if you want to test something a little bit different, but still running there on the not stealing mode, on the mirror mode, is something that's very unique, I think.
Yeah, and as I said, it's very similar to the workflow of just debugging a local process, but now you're running it in cloud context, and we can see now that we're running both of these processes simultaneously. So your name is still on there from the product page, and now the ratings have changed from the ratings service, so they're both 1 star.
But like you said, can I have, for example, I'm stealing, but can I have the files from the cloud?
Sorry, say again. What do you mean?
Can I have, let's say, some things from the cloud and some things from the local environment? Let's say, if I have a file dependence, like attachment or file dependence that's on the cloud, I don't have on my local environment. Can I have this mix between what's here and what's in there?
Yeah, absolutely. So the MirrorD-JSON has this section, the FS or file system configuration, and it's very composable. So, oh, great, there we go. So,
wow, that's amazing.
yeah, you can really, you can decide what files will be read locally, what file will be read remotely, what file will be read and written remotely. So there's a very detailed configuration. I don't remember the exact syntax, so I'm not gonna, try to execute it. But
I never saw that. I don't think I ever saw that on the product. I mean,
yeah.
That flexibility to have these mix of things and you decide.
And this is what, because there have been solutions that have tried to do similar things before, but they're very hard to adopt because they run into these technical walls, because everyone's deployment is sort of unique. Everyone needs like these little different mixes of configurations. And MirrorD's power is that it supports that. So you can really match or adapt the configuration to make it work for you.
Yeah, that's exactly. And ours will be different. Each one will be a different requirement, and you can just do your configuration file the way that you want. Even for different servers, will be different. And when you debug more than one at once, it could be debugging the front end in Python, debugging the microservice. That would be a separate Visual Studio instance, or
Yeah, right now I have two
Visual Studio code open.
Yeah, exactly.
Okay.
Yeah, and I'm debugging these two services simultaneously. So, yeah, and because MirrorD works at the process level, as opposed to some other solutions that work at the system level, sort of VPN, sort of, etc., then it's no problem. You can run as many processes within as many different contexts as you'd like.
Yeah. And then I'll give another example about, I don't know if you have it. I haven't asked you before yet, but let's say DNS resolution. I have a database running on Azure, and I have another dependency running on Azure, and I have something that I could be, like you said about the database is one option. Is that done by DNS resolution, or to point to the local? Is that how it works?
Yeah, so I want to say something a little bit more general about that. So, one of the objections to MirrorD is that it mutates the environment, right? Because you have outgoing traffic, file writes, etc., and you can make changes to the environment. So when we say that it's non-invasive, that it can be concurrent usable, then it's not completely correct. And of course, it's not black and white, but MirrorD gives you the tools to handle that. So one of those is, as you mentioned, being able to decide what's happening locally, what's happening remotely. And if we take the database example, if I don't want to write to a remote database, then I have the same sort of granularity in outgoing, right? So let me, yep, there we go. I think, yes, local, so I can tell them, my database host name happens locally.
And on remote.
Yeah, and well, I don't have to specify because everything else is going to happen remotely. And all of these, they support wildcard or regex syntaxes, so you can it's very flexible. You can do whatever you want. Yeah, so that lets you avoid mutating your environment if you care about it. Maybe you want to write to a database and it doesn't really affect concurrent usage of your environment, but if it does, then you have that option. And another topic that comes up when discussing this is queues, right? So what happens if my application, instead of being sort of an HTTP server that's activated by incoming traffic, what if it's activated? It's event-based. It reads from a queue. So what's going to happen in sort of the naive execution of MirrorD is that your local process and the remote process that's still running will compete from the same. They'll both try to read the same messages from the queue, and they'll compete. So of course that's not great. And at this point, you have to put a disclaimer that the features that handle this are supported only in the paid version of MirrorD called MirrorD 14. Everything we've seen so far is supported in the open source. But what it provides is a feature called copy target, copy and replace, which lets you scale down the remote service so it doesn't compete with you for the messages and lets your local service read everything. And what we're currently working on, which is really cool, is a selective reading of queues from a message. So of messages from a queue. So you'd be able to specify a filter that would let you only read some of the messages and leave everything else for the stable service running remotely. So it's going to fulfill that promise of concurrency for queue-based services as well.
That sounds great. And you can see the pillars that is like networking, file system, and environment variables as well. Anything on those three pillars, and now message queue, like you said, like is coming probably be another pillar there that's you can do whatever, pretty much whatever you want, and how can you can configure incoming, outgoing networking, file system, where that's going, and that's very flexible. And I can see a lot of use case. I don't know what's the most popular use case that you wanna like. Is that you show us microservice, database, message queue, file system. But I see Miro.D also be used by the SIEs that are managing the product, and they want to debug something that's running in production sometimes, or even running in a test environment, in a UAT environment. And sometimes they don't know what's going on there. And I think Miro.D can help them to find out what's going on, easier than just looking logs.
Yeah, well, I have to say we don't encourage using Miro.D in production.
Yeah.
So, but yeah, absolutely. But I think there's an interesting thing to be said about the use case, because initially Miro.D is usually perceived as a debugging tool, right? So maybe I have a problem that's only happening in staging, so I'm going to use Miro.D to debug it. But as you become more confident or more acquainted with Miro.D, you realize it's a day-to-day development tool, because now whenever you write new code, instead of finding out ways to test it locally, simulations, mocks, etc., then you can just test it against staging continuously, because you saw it takes like 2 seconds. So why not? So write new code, test it in the cloud, skip all of the steps in the process that you're currently doing to sort of replace that. Yeah.
Yeah, exactly. I see like a pre-prod environment could be used in a pre-prod environment or a UAT environment, like a pre-prod that would be like similar to production. And sometimes they want to maybe do a canary deployment. It gets 5% of the traffic sometimes, and I know there is a risk you touch in production is not good. Then I see more like UAT, and I don't know, it's something for you to work in a feature how they could use something to debug in production without having any risk.
Yeah.
Let's say if I do a canary deployment, I get 10% of the traffic only from my local environment, or only from my testers, let's say, but running there. And could I do something on that or not? And yeah, I don't see production anytime soon, but I see a very pre-prod, very similar production environment where they find the bugs, they don't know how to fix it. Nobody can find the bug, and I can see the SIEs, pushing these environments and try to find the problems in there, and try to fix, like change environment variable, change some configurations, and see if it works. And if they find the bug, they do a quick fix and they retry, and I probably easier and faster to debug than try to look in the logs.
Yeah, and by the way, the original idea for Miro.D was production, but we got shot down so hard on Reddit and Hacker News that we immediately retreated to staging. But yeah, we know that there are some people that use Miro.D, the open source, in production. Of course, we can't it's a lot of work to get the enterprise paid version ready for something like this. Like it's a whole new kind of worms. So.
Yeah, I have a question. Let's say something that you do is similar to like a sidecar container that you do on Service Mesh. You agree? Like you are intercepting the traffic, and you are sending the traffic there, and and those people do things in production, like that's running in production. Those sidecars are running in production. I don't see why I cannot revisit one production idea, maybe a different way, not the same way that we're doing here, but. Yeah, I can see some things in production thinking that you're just creating an extra container on your pods with the same namespace of the pod, then you're doing things that there's a risk because you need permission to do that on the cluster. And tell me about that security. How is what kind of permission I need to run that in my AKS cluster, for example?
Okay, so for the Mirror open source, like what Mirror does is create a pod, right? The Mirror agent. So you need to be able to create a pod. It requires some extra privileges. I don't remember them exactly, but they're listed on our documentation. So that's for the open source. And I'll say a few words about the paid version at this point. In that the difference between the open source and the paid version, we see the open source as the as a solution for individual developers or for like initial experimentation with Mirror or for small teams. But the paid version is what makes Mirror adoptable within an organization and enterprise on a large scale. And so it adds layers of management, of security, auditability, collaboration, etc. And what the paid version adds is a component called the Mirror operator, which orchestrates different instances of Mirror on the cluster. And it gives the admin control over what exactly can be done or not done with Mirror on a centralized level. And back to your question, with the operator, then individual developers don't need permission to create pods anymore because only the operator is the one that's creating the Mirror agent.
Yeah, that's a little bit different approach as you're going to manage now the security side with the paid version. Then it means that if your working environment's more, pre-prod, where you even have like some production data or similar to production, probably safer to use some paid version where you can leverage those things. And I told you before, I wanna see how can we bring this to the Azure Marketplace.
Yeah.
We need the open source and the paid version on the marketplace, that to be easier for them just to to install and have the extension that they want to use on VS Code or IDE that they're going to use, and have these. I think, and that'll be great. Some people ask about bridge to Kubernetes or the products. I think Mirror is a different approach. It's something that we're now competing with products on all the products. Is a different approach, and it's something that's very handy and useful for so many use cases that we cannot support, and we're not going to support anytime soon. And then it'd be nice. And if you're watching this, that's the reason. There's no, it's a product that really complements and come to fix problems that we haven't done yet, haven't fixed it yet, and they have the solution. And thanks a lot, Eyal, for that. There's anything else you're going to show or you want to say? I have your links here just for the GitHub again, the Metal Bear Mirror project. How long is the project, by the way? How long is on?
We started it 2.5 years ago. Yeah, and the paid version has been in development for about a year, a little bit more.
Nice. Yeah, it's growing. It's growing. I can see, people talking about. I can see the posts. I can see a lot of developers talking, even inside Microsoft as well. And I put here on X, if you want to follow on X. So LinkedIn, there is a page there. I can see guys start posting things. And I saw one thing. Let me share my screen just for us to finish. Say that was selected by. I see some blog posts recently. Maybe I can put on the recording. I'm going to put on the video description there, and I can see that you did like a couple of videos and some blog posting from the community that I think was very interesting. And I'm going just to post on the video, comments there, the links that I found. And it's one of the tools that you need now if you work with Kubernetes. Thanks a lot again, Al, and talk to everybody soon.
Thanks so much for having me.
Pleasure.